Hi guys, and happy cold day. I want to just give you a quick reminder of what we did last Friday. So the Friday would have been on January 25th. Yesterday, January 28th, we had a cold day. Today the teachers are in school working on making videos for you guys. So on Wednesday and Thursday, you guys can work from home. All right, so just a really quick reminder of what we did. We simplified radicals and expressions with a rational exponent. Really quick, simplify, just a couple things. If you look at your notes, we had different roots that we looked at, and we talked about different strategies on how to approach those or how to simplify those. The first strategy was thinking about what's the highest perfect square divisible by the radicand. So when we look at 27, we saw that 9 was the highest perfect square. The square root of 9 times the square root of 3 gets you 27. The square root of 9 is 3, so 3 square roots of 3. Strategy 2 will always work for you if you're in a jam. You prime factor that. And with square roots, we look for pairs. So we see a pair of x's, a pair of y's, and another pair of y's. We bring those out of the radicand outside here, and then we multiply to get 3xy squared times the square root of 2x. Next, we simplified cube roots. Strategy 1, we could have thought about what's the highest perfect cube divisible by the radicand. But strategy 2 is one I focused on a little bit more, especially with cube roots. We prime factored 81. 1, 2, 3, 4 threes make up 81. We looked for groups of 3. We have one group of 3, and we have another group of 3. So we have 3x on the outside. And this little 3 here is not 3x cubed. It's the cubed root of 3x, which is what's left over. Finding the product, we talked about, okay, what are we going to do? We're going to multiply these outsides to get 6, and we're going to multiply the inside to get 75. Then we need to simplify whatever strategy you need. So if you want the highest perfect square like we did here, 25 goes into 75 3 times. Or if you want to prime factor it, either way we got 30 times the square root of 3. Moving on, we talked about finding the sum and difference. We talked about how all the roots need to be simplified using either strategy that we just talked about, and then we combine like roots. Here, the square root of 12 was simplified by using strategy 1. The highest perfect square that goes into 12 is the square root of 4. The square root of 4 times the square root of 3 is 12, which is 2 square roots of 3. They are now like terms. We can combine them to give us 5 square roots of 3. Then finally, we talked about rational exponents and going from rational exponent notation to radical notation. And we said, hey, if you're in a jam, always you can label them. Here's my A, here's my M, here's my N. Now let's put it in radical notation. Here's my N, here's my A, here's my M. We then talked about going the other way, rewriting using a rational exponent notation. Here's my A, here's my N, here's my M, and then going back, okay? So being able to go back and forth in our notes. We then talked about this problem, which I liked, because what happened? Well, we were missing an M out here. We're also missing an N. So we talked about what is M and N equal to when that happens. And then finally, we talked about evaluating without using a calculator, and that's where we want to put it in radical notation. We then want to prime factor and either look for a group of 3 if it's a cubed root, or a group of 2 if it's a square root. We found out that the cubed root of 64 is 4. That's the inside here, and then we need to raise it to the second power. 4 to the second power is 16. And that sums up in a nutshell what we did on Friday. Your homework for today will be to work on page 417, 3 through 33, and that will be on Schoology for you guys. Have a great day.